Hi everyone. Today, we're diving into a specific data compression error. It's often seen with Zlib and is called invalid distance too far back. This message can be confusing. It usually means something went wrong during compression or that your data is corrupted. We'll break down what causes this error. Then, we'll discuss potential ways to modify Zlib to handle it, along with important warnings. First, let's understand the cause. Zlib uses the DEFLATE algorithm. DEFLATE works by finding repeating patterns in your data. Instead of storing the repeated data itself, it stores a small pointer. This pointer has two main parts, a length and a distance. The length tells you how many bytes to repeat. The distance tells you how far back in the already processed data to look for that pattern. Imagine you have the text banana banana. After the first banana, DEFLATE might say repeat 6 bytes from 6 bytes back. The distance here is 6 bytes. The DEFLATE standard, which Zlib follows strictly, has a maximum limit for this distance. This limit is 32,768 bytes, or 32 kilobytes. This means a back reference can only point to data within the last 32 kilobytes of decompressed data. If Zlib tries to decompress data where a distance value is larger than this 32,768 byte window, it triggers the invalid distance too far back error. It's trying to look for data that is simply too far away according to the standard. Why does this happen? Most often, it's due to corrupt compressed data. A single flipped bit can drastically change a distance value. Another reason could be that the data was compressed by a non-standard or buggy compressor. This compressor might have generated DEFLATE streams that do not comply with the official specification. Less commonly, memory issues during compression or decompression could also contribute. Now, let's talk about modifying Zlib to fix it. It's crucial to start with a strong warning. Directly modifying Zlib's core decompression logic is generally not recommended. It can introduce serious stability and security risks. The safest approach is usually to ensure your input data is valid. If the data is truly corrupt, modifying Zlib won't magically recover the original information. However, if you are in a very specific scenario, perhaps dealing with data from a unique hardware device or legacy system that generates slightly non-compliant DEFLATE streams, you might consider it. The core of the issue lies in Zlib's inflate function, which performs checks like dist max_dist. Max_dist is the 32,768 byte limit. One highly risky approach would be to find and increase this max_dist constant in Zlib's source code, for instance, in files like inffast.c or inflate.c. You might find it defined or implicitly derived from bits. By increasing this value or disabling the check, you would allow Zlib to accept larger distances. But, and this is a big but, doing so violates the DEFLATE standard. It can easily lead to buffer overflows. If dist points outside the allocated decompression window, your program could crash. Worse, it could be exploited by malicious data to write arbitrary data to memory, creating a severe security vulnerability. You would essentially be creating your own non-standard DEFLATE decompressor. A much safer and more common approach is to handle the z_data_ error gracefully in your application code. When inflate returns this error, your program should catch it. You can then log the issue, skip the problematic data block, or attempt other forms of error recovery. This prevents your entire application from crashing and maintains security. It acknowledges the data is bad without trying to force Zlib to process it incorrectly. Pre-processing the data to fix invalid distances before Zlib sees it is another complex but potentially safer option, though it requires deep knowledge of DEFLATE. In summary, the invalid distance too far back error indicates a DEFLATE back reference exceeding the standard's 32 kilobytes window. It almost always points to corrupt or non-compliant compressed data. Modifying Zlib's internal checks to relax this limit is extremely dangerous and can lead to severe security flaws and instability. The best practice is to handle the z_data_ error in your application and ensure your input data is valid. Thanks for watching this explanation of a tricky compression error. If you found this video helpful, please give it a thumbs up. Don't forget to subscribe to the channel for more technical deep dives and practical advice. See you next time.